Okay, so I'm going to make my own little video here and hopefully bring about some clarity in regards to logarithms and their exponential form, and maybe clarify what the instructor was saying in his video. I think part of the confusion may have come from he used terms interchangeably that I wouldn't, and he wrote a little sloppily, which maybe made it look a little wonky. So let's just start from where he started, which is that we have, let's say here, logarithm or log A, base A, of B equals X. So I would call this whole thing an equation. I guess in the broadest sense, you could consider it an expression because the way it's written, A and B are constants, so really it's just X is equal to some value. Nothing's changing. But really, once you have an equal sign, you kind of have an equation. So regardless, what we have here is that X is equal to this entire thing. Logarithm is an operation and also a function, which doesn't really matter in this situation. But what needs to be clear is that X is equal to that entire thing on the left-hand side. Log base A of B. So this is not saying X is equal to B. It is saying that X is equal to the log of base A of B is, okay? All right, so when he changes it, or he writes this exponential form, he writes it as base A of the exponent X is equal to B. Now what he's saying here is that it's not X equals B, it is that A raised to the X is equal to B. Again, this whole thing is equal to B. So why are these equivalent? They're equivalent because you can rewrite either of them as the other one. So you have, I'm going to work on this left-hand side here. I'm going to take this guy and convert it. So what I would do is I would say, well, I'm going to take this base A and I'm going to move it over and make it the base on this other side. Because I'm removing the base from the logarithm, I no longer have a logarithm. It's not valid. It disappears. So when I do that, that A shifts over to the other side, I'm going to be left with just B on the left-hand side. And it is now going to be equal to this base A raised to the power of X. Which, I mean, we can see is the same as what we have on the right-hand side at the top. They're just reversed, which is totally valid. We can read from left to right or right to left when it comes to equality. We're saying that B is equal to A of X, or A of X is equal to B, means exactly the same thing. Those are the same. But these two guys are equivalent statements. These two guys are equivalent statements because I can change the form. So B is not equal to X in either scenario. These are two different equations. I wouldn't necessarily call them expressions. I would call these equations. But they're equivalent because I can rewrite them, right? So I could also take this one over here and do the same exact thing. I could rewrite it as a logarithm by taking the base of this exponent bringing it over to this side of the equation. When I do that, it's going to leave the x behind, which now becomes its own base. And it's going to be equal to the log, which a is the base of b. That is an ugly b. So now I've rewritten this exponent as a logarithm. So they are in some sense interchangeable, but they are equal to different parts, if that makes sense. One of them, x is equal to the log a of b, and in the other one, b is equal to a of x. If we were to start throwing some numbers in there, using something that we are familiar with, maybe, let's say I have something that we were playing with. How about log of base 2 of 8 is equal to x. I could rewrite that as an equivalent statement where 8 is equal to 2 to the x. Now, in this case, x is a single value, right? And that value is what? 3. All right, 2 to the third power is equal to 8. 2 times 2 is 4, times 2 is 8. So in both cases, x is equal to 3, but there's just written completely differently. One is written as a logarithm, one is written as an exponent. They are equivalent statements. X holds the same value. But you can see that x is not equal to 8. X is equal to log base 2 of 8. And over here, 8 is not equal to x. 8 is equal to 2 to the x power. And in both cases, x just so happens to equal 3. I hope that was maybe some clarification.